All right, hi everybody. Here's question 115 from chapter 6. This is describing a thermodynamic system where 20 liters of a volume of ideal gas in a cylinder is initially at a pressure of 3 bar. The pressure is halved and the gas expands at constant temperature until the pressure is 1.5 bar. And we're asked to find the change in internal energy, enthalpy, as well as the heat and work involved in this change of state. Okay, so for the thermodynamic questions, especially if you guys have physical chemistry coming next year, if you're in the pharmaceutical or the biochem or straight chemistry programs or anything like that, anything you got to take PChem for, it's good practice to keep in mind which of the values you get for free under certain conditions. In this case, because this is isothermal, that is going to greatly simplify this, because both internal energy and I really mean and, not plus in this case. So internal energy and enthalpy are both functions of temperature, meaning that if the change in temperature is equal to 0, then neither of these values change. So this is going to be equal to 0, and this is also going to be equal to 0. So we get delta U and delta H from the question, just because of the isothermal restrictions. That leaves us for work and heat. Now, because we can write the first law of thermodynamics as such. Sorry, excuse me. Like such, and we know that this value is 0, then that means that work is going to be equal to negative heat, or vice versa, however you'd prefer to look at it. And we do have pressure and volume in this case, so there is going to be some work involved. So we can calculate the work as the negative external pressure times the change in volume. So we have negative, we want an answer in joules. So the 1.5 bar I'm going to change to kilopascal. So that's 150 kilopascal. We have 40 minus 20 liters is going to give us 20 liters as the difference here. This is going to give us a total of negative 3 times. Well, let's go negative 3 kilojoules of work. And so that means if work is equal to negative 3 kilojoules, that means that the heat is equal to 3 kilojoules because of this negative equals positive relationship here. All right, there you go.